Welcome to the deep dive. For you listening right now, the mission for today is highly specific and honestly a little mind-bending if you've been spending your days wrestling with AI tools.
Yeah, it really is.
We are looking at the Model Context Protocol, but we are not looking at what it is on paper. We covered the technical specifications in MCP 101.
Right, the spec is old news.
Exactly. Today, we are exploring the actual behavior shift it creates when it is running live in your environment. Think of this as MCP 102, Claude already knows.
I love that title. And to do this properly, we're pulling from a really fascinating stack of sources today. We have Anthropic's official MCP launch announcement, which sets the stage for the standard. We also have the incredibly comprehensive technical documentation from N8N on their MCP server integration.
Which is dense, but so good.
Very dense. And finally, we have some detailed practitioner notes documenting a real-world test run that really brings this all to life.
I want to jump straight into those practitioner notes because there is a story in there that completely hooked me.
The wireframe one?
Yes, the wireframe story. It illustrates the behavior shift perfectly. So the author of these notes, who we'll just refer to as the host, was working inside Claude code.
Yeah.
They were right in the middle of a project, deep in the weeds of building out a new feature. MCP was configured, meaning Claude was actively connected to both their Notion workspace and their self-hosted N8N instance.
So the context was loaded.
The context was fully loaded, but the critical detail in the notes is the sequence of events. The host hadn't actually prompted Claude to do anything specific yet.
Meaning there was no prompt sitting in the terminal. No, please generate X based on Y.
None at all. And that's where it gets strange. The host steps away from the keyboard for a bit, and without being asked, Claude reads the active project context from the Notion workspace, infers the next logical step for the project based on the documentation, and just drops a fully working wireframe right into the local repository.
Wow.
Right. But it wasn't just a standalone dead wireframe. It was fully wire up to a mock backend environment in 8N.
Without a single command.
Without a single command. The host only noticed when they checked back in later, there was a wireframe draft and a configured mock workflow just waiting for them.
That is exactly the moment we want to focus on today. That is the moment where MCP stopped being just an abstract technical specification and started making sense as a fundamental change in behavior.
Yeah.
Because we aren't here to give you a step-by-step coding tutorial. We're having an honest conversation about what this technology actually does when you flip the switch. As practitioners, it is genuinely surprising to see an AI system move from a passive responder to an active participant.
Okay, let's unpack this, because to really appreciate the behavior shift, we have to talk about the baseline experience, the life we all lived before MCP.
The amnesia problem.
The amnesia problem. Without it, every single AI session wakes up with complete and total amnesia.
It is the defining friction of the current era of AI tools. You sit down to work, and the model is incredibly capable. It has passed the bar exam, it can write flawless Python.
Yeah, it's brilliant.
But its immediate memory of your specific world is totally blank.
I call it the human tax. Think about the sheer mechanical effort of the standard workflow right now. You have to constantly repaste the project brief.
Every single time.
Every time. You have to restate the technical constraints. You have to re-explain what you are building, why you are building it, what the database schema looks like, what the design system guidelines are.
Right.
Every single time you open a new chat window. The AI is highly capable, but because it starts completely blind, you spend half your energy just bringing it up to speed. It's exhausting.
If we look at the Anthropic announcement, they hit on this exact problem. They specifically noted in the release that the industry has poured massive investment into model capabilities, leading to rapid advances in reasoning.
Sure.
But they pointed out that these sophisticated models have remained severely constrained because they are isolated from our actual data. They have been trapped behind information silos.
But let me push back a little on the trapped framing. It's not that we haven't tried to connect them. We've had APIs and custom plugins for a while now.
True.
The problem was that historically, every single new data source required its own bespoke, brittle integration. You couldn't just plug your AI into your entire digital life easily.
That's a fair distinction. It's actually worse than the data just being locked away. It's that legacy systems force the human to become the API.
Oh, that's a great way to put it.
Because building a custom integration for every tool in your stack is unscalable. You, the human, are forced to become the manual data pipeline.
Copying and pasting.
Copying and pasting from your company's Notion page into the chat window and then copying the output back into your code editor.
Which brings us to the shift. What actually happens when you configure MCP? The fundamental difference is the starting point. When you sit down to work, Claude already knows.
And that changes the entire paradigm of the interaction.
Claude can now see your Notion docs. It can look at your project folders on your local machine. It can see your automation workflows in any N. It simply doesn't start from zero anymore.
Right.
But how is it doing this without just constantly scraping everything in the background and burning through tokens?
The technical concept we need to ground this in is resuming from state.
Resuming from state.
Yeah. In software development, state refers to the current condition of an application or a system at a specific moment in time. When we say the AI is resuming from state, we mean it is picking up exactly where the project currently stands, dynamically.
Dynamically, so it's not reading a static export.
No, it's not reading a static export of your Notion doc from yesterday. It's reading the live state.
So if I update the acceptance criteria in Notion and then tab over to Claude Code in my terminal, Claude is already operating under the new criteria.
Provided the Notion MCP server is configured to expose that specific workspace, yes. And because of this constant connection, the practical result for you is a massive reduction in back-and-forth dialogue.
The friction just drops.
Exactly. There are drastically fewer clarifying questions. There are no more frustrating moments where Claude stops and says, "Can you please paste the technical specifications again?" It has exactly what it needs to act immediately.
But we need to make a very crucial distinction here, because I think a lot of people hear Claude already knows, and they assume the model itself is learning.
Oh yeah, that's a common misconception.
MCP does not give Claude internal memory. It is not suddenly remembering your conversations from last week through some massive persistent neural network update. It's not fine-tuning itself on the fly.
What's fascinating here is how Anthropic designed this architecture. What MCP does is give Claude structured access to your external memory. It's a client-server model.
Right. It's not hoarding your data inside the LLM's weights.
Anthropic specifically emphasized this in their documentation. They didn't build a proprietary database to suck up your information into their cloud. MCP is a universal open standard. It replaces all those fragmented custom integrations with a single two-way protocol.
Which is huge.
Anthropic specifically noted in their release that we are moving from isolated chatbots to integrated agents. And to get to integrated agents, you need a standardized way for the agent to query the outside world.
And the ecosystem that is already springing up around this open standard is wild. I mean, Anthropic released several pre-built MCP servers right out of the gate. We are talking Google Drive, Slack, GitHub, Git, Postgres, Puppeteer.
It's a very robust starting lineup.
They mentioned early adopters like Block and Apollo already integrating it, and the development tools space is jumping on this. Companies like Zed, Replit, Codam, and SourceGraph are using MCP.
Let's pause on a couple of those because they illustrate the power of external memory perfectly. Take the Postgres MCP server.
Oh, that one is huge.
Without MCP, if you wanted Claude to help you analyze user data, you'd have to write a SQL query yourself, run it in your database client, export the result as a CSV, and then upload that CSV to Claude.
The manual human pipeline again?
Exactly. Yeah. With the Postgres MCP server, Claude has structured access to the database itself. You just ask the question. Claude writes the query, executes it against your database via the MCP server, reads the result, and gives you the analysis.
And the Puppeteer server is even crazier. Puppeteer is a node library that provides a high-level API to control Chrome or Chromium. So the Puppeteer MCP server basically gives Claude a web browser.
Right.
If you ask it to check a competitor's pricing page, it can actually spin up a headless browser, navigate to the URL, read the DOM, and report back. It's pulling the exact book from the shelf that it needs dynamically.
That library analogy is perfect. Without MCP, you had to shove the entire contents of the library into the AI's prompt every single time you asked a question.
Just dumping text.
Yeah. With MCP, the AI can just walk into the library, look at the index, and pull the specific book. And it leads us right into the specific setup that made that wireframe story possible, the three-tool stack.
Let's break down that exact configuration because it is incredibly elegant, but I want to know if it's actually as smooth as the practitioner notes claim. The notes detail a stack consisting of Anthropic MCP, Notion MCP, and NAN MCP.
The notes indicate that setting this up was remarkably straightforward, relying on solid official documentation for each layer. It wasn't dependency hell, it was just normal tinkering friction. Let's look at the architecture.
So layer 1, Anthropic MCP. This handles the core Claude integration inside Claude Code, or the Claude desktop app. Basically, Claude Code speaks MCP natively. It acts as the foundational host, the client that everything else plugs into.
Layer 2 is the Notion MCP server. This is what gives Claude access to all those project docs, meeting notes, and the broader context. Instead of pasting the project brief into the chat, Claude simply queries the live Notion document via the server.
So the brief is the brief.
The brief is the brief.
And then we have layer 3, the NAN MCP server. This is the bridge that connects Claude to your actual automation workflows. And I want to spend some real time here because the NAN documentation provided in our sources is incredibly rich and reveals a lot about how these systems actually interact under the hood.
Let's dive deep into that. For those who might not be familiar, NAN is an open source automation platform. It allows you to visually build workflows that connect different apps and APIs together.
Kind of like Zapier, but open source.
Exactly. But the crucial detail, especially for the enterprise context we'll discuss later, is that you can self-host it. You keep your data entirely on your own machine or your own private cloud.
But how does the MCP integration actually work within NAN? Because the docs highlight two distinctly different ways to give Claude access: instance-level MCP access and the MCP server trigger node. Why would you choose one over the other?
The difference between those two is fundamentally about scope and security. Instance-level MCP access is centralized. If you enable this, it lets the connected client Claude search through and trigger any eligible workflows across your entire N8 instance.
It just sees everything.
Everything eligible. It's a broad, centralized connection designed for a single user who wants their AI to have the run of the house.
That sounds incredibly powerful, but also slightly terrifying if you make a mistake. What's the alternative?
The alternative is the MCP server trigger node. This is scoped strictly to one specific workflow. You physically place this node onto your NAN canvas inside a single workflow. It only exposes the tools defined within that specific boundary.
Right.
It's a much more targeted approach. If you only want Claude to have the ability to trigger a specific deployment script and absolutely nothing else, you use the node.
But even if you go with the broad instance-level access, the docs are very clear that it isn't a free-for-all. NAN has strict rules for workflow eligibility. You can't just let Claude run wild through every half-finished draft workflow you've ever created.
Right. For a workflow to even be visible to MCP clients, it must meet specific criteria. First, it absolutely must be actively published. The server completely ignores drafts.
Which is smart.
Second, the workflow must contain specific types of starting triggers.
The docs list them specifically: webhook, schedule, chat, or form triggers. If a published workflow has one of those, it can be exposed to Claude. But here's the interesting part. The moment you unpublish a workflow in NAN, it instantly severs its MCP access.
Right.
Claude immediately loses the tool.
And then there's the authentication layer. How does Claude actually prove it has permission to talk to your NAN instance?
Right, because you don't want just any local script pinging it.
Yeah, exactly. The documentation outlines two paths here. You can use OAuth 2, where N8N redirects you to an authorization screen, similar to sign in with Google.
Or you can use auto-generated personal access tokens, which makes sense for a local terminal-based tool like Claude Code. But as I read through the NAN docs, I noticed they outline some very hard guardrails on MCP executions. They don't just let Claude trigger a workflow and walk away.
The most significant guardrail is the timeout. The NAN documentation explicitly states that executions triggered by an MCP client enforce a strict 5-minute timeout.
5 minutes?
If the workflow doesn't finish within 5 minutes, NAN just kills the process and sends an error back to the client. And it completely ignores any custom timeouts you might have set within the workflow itself.
Wait, if the NAN timeout is a hard 5 minutes, that means Claude can't just spin up a massive data processing job like encoding a video or training a local mini-model and just wait for the result. That forces a completely different kind of architecture, doesn't it?
Exactly the right question to ask. A 5-minute timeout forces the developer to design micro workflows. Claude has to become a manager delegating quick, discrete tasks rather than running monolithic, long-running scripts.
It keeps the system responsive.
It ensures the AI doesn't get stuck in an endless waiting state, burning through its context window, or completely locking up the local machine's resources.
They also restrict the type of data that can be processed. The NAN MCP doesn't support multi-step forms.
Oh, that's a big one.
Yeah, so there can be no human-in-the-loop interactions where the workflow pauses, pings you on Slack for approval, and waits for your response mid-run. It has to be a straight shot. And it does not support binary input data. Claude can only send text-based inputs like JSON payloads to trigger these workflows.
If we connect this to the bigger picture, all of these technical details, the scoped access, the strict eligibility rules, the 5-minute timeout, the text-only inputs, they're all serving a single purpose.
Guardrails.
They're creating a safe, reliable, and predictable bridge between the AI's probabilistic reasoning capabilities and your deterministic execution environments.
Okay, let's unpack this, because all of these technical constraints and server architectures are fascinating, but what does this all mean for the person sitting at the keyboard? It fundamentally changes the texture of the interaction.
Interaction texture is a great way to phrase it. How does it actually feel to use?
Before MCP, working with Claude felt like briefing a highly capable contractor. Imagine you hire the best contractor in the world to build a house, but they show up to the job site every single morning with zero memory of what happened yesterday.
Right.
You spend all your energy reloading their brain, handing them the blueprints again, explaining the zoning constraints again, pointing out where the plumbing goes. They do great work for the day, but the next morning, they are a blank slate again.
After MCP, the texture shifts from contractor to collaborator. It feels like working with a teammate who actively read the project file before they came to the meeting.
Yes.
They know the constraints, they know the history. They can just act without needing their hand held.
Which brings us full circle to that incredible wireframe story from the practitioner notes. When you understand the stack, the Anthropic client, the Notion external memory, the N8N execution environment, the story makes complete sense.
The host didn't type, "Please generate a wireframe." Claude, acting as a collaborator, saw the updated project brief sitting in the connected Notion workspace.
It read the room.
It used its reasoning capabilities to deduce what the next logical deliverable should be based on that brief.
It built the wireframe code, and then because it had that structured access to external memory and tools via the N8N MCP, it sent a JSON payload to an N8N webhook trigger.
Beautiful.
That trigger spun up a mock backend environment, and Claude wired the front-end code to it. It stopped feeling like a passive tool waiting for a prompt and became a true collaborator doing asynchronous work between human check-ins.
It is a profound shift in how we relate to these systems. We are moving from prompt engineering to systems engineering. But the beauty of this protocol is that you don't have to take our word for it.
I want to empower you to try this yourself. You do not need to set up that massive 3-tool stack to feel this behavior shift. You don't need to be a developer running a self-hosted automation platform like N8N. You can experience this delta in about 15 to 20 minutes.
There are two main paths you can take to experiment with this, depending on how you prefer to work and what tools you're comfortable with.
Path A is for folks using the Visual Claude desktop application. If you open the app, go to Settings, and then click on Extensions. You will see a directory of available servers. Pick just one server for a tool you already use every day.
Notion is a great one if you use it for notes.
GitHub is another. Or even just the local file system server, which lets Claude read files directly on your computer.
The official servers listed in that directory are incredibly user-friendly. They are essentially one-click installs. You don't need to be editing complex JSON configuration files or managing node environments to get them running.
Once it's installed, open a brand new conversation in Claude Desktop. Ask it a question that requires context from that tool, but crucially, do not paste anything into the chat.
The no-paste rule.
Exactly. If you installed the Notion server, ask it to summarize the latest changes to your project brief. If you installed the file system server, ask it to look in your Documents folder and find the common themes in your last 3 reports.
Path B is for the tinkerers who prefer the command line and are using Claude code. Open your terminal and run a specific command to add the file system server.
What's the command?
You type Claude MCP, add file system npx tca, at model context protocol server file system path to your project. You point that command at an active project folder on your machine.
Then, start a session in the terminal and just ask Claude about the project. Say, what dependencies am I missing in this project? Or where is the authentication logic handled?
The goal of this experiment, whether you take path A or path B, is to notice the delta. Notice how few clarifying questions Claude asks you compared to a standard non-MCP session.
It's night and day.
Notice how it doesn't ask you to paste the package.json file. That difference, that delta in the interaction, is what the protocol actually delivers.
It's not magic. It's not some sci-fi leap in artificial general intelligence. It is just structured context reliably passed to the AI in a way it can naturally use.
But the implications of that simple mechanism are massive, which brings up the operator verdict from our practitioner notes.
Here's where it gets really interesting. If you are an individual tinkerer running Claude Code or Claude Desktop locally on your own machine, the verdict is that adoption is a total no-brainer.
Absolute no-brainer.
The friction to set it up is low, and the improvement to your daily workflow is immediate and undeniable. It makes you faster and less frustrated.
But if we look at the enterprise space, the picture changes dramatically.
Yeah.
The exact things that make MCP so incredibly powerful and frictionless for the individual tinkerer are the exact things that create a security nightmare for enterprise IT teams.
Think about it from a chief information security officer's perspective. One click installs of servers that connect AI directly to your local file system.
That's terrifying for them.
Local servers running on employee laptops without central approval. A highly capable AI agent that suddenly has read and write access to internal company documents, source code repositories, and automation workflows.
This raises an important question about governance. Right now, in most real-world ground-level setups, there is a massive governance void. There is no centralized, standardized policy layer that dictates which MCP servers an employee's Claude instance is allowed to access.
There is no central dashboard restricting what resources are exposed. How does an IT admin ensure that Claude isn't reading the HR salary database through a Postgres MCP server?
They really can't.
Right. How do they log the tool calls for compliance audits to see exactly what queries the AI executed on behalf of the user? Right now, they really can't. Not easily.
We can see evidence of this gap directly in our sources. Look at the N8N documentation. If an enterprise wants to disable MCP access on their self-hosted instance because they're worried about security, they can't just uncheck a permissions box for certain user groups or limit it by IP address.
No granular control.
They have to set a blunt system-wide environment variable NA disables and ND disable modules MCP.
Which completely hides the UI and shuts down the endpoints for everyone across the entire instance. It's an all-or-nothing switch. You either have the Wild West or you have nothing.
Anthropic is clearly aware of this gap. In their announcement, they specifically noted that they will soon provide developer toolkits for deploying remote production MCP servers that can serve an entire organization with proper authentication and access controls.
Soon.
Soon, exactly. But right now, today, in highly regulated environments like finance or healthcare, this lack of granular governance is a massive gap. The capability has arrived, but the governance conversation hasn't caught up yet. It is definitely a topic we will have to tackle in a future deep dive as those enterprise toolkits roll out.
As we wrap up our analysis of these sources, I am struck by how quickly this moves from a cool developer tool to a fundamental architectural shift.
And I want to leave you with the final thought to mull over. Building on everything we've discussed today, we've talked extensively about a single AI tool, Claude, gaining structured access to our digital memory and having the ability to act on changes in state through tools like N8N.
Yes.
But what happens when multiple different agents are plugged into the exact same N8N environment and the exact same Notion workspace?
Yeah, so we're talking about a cascading loop.
Exactly. Could these different AI agents start reacting to each other's state changes asynchronously? Could Agent A, tasked with market research, update a Notion doc,
which then triggers Agent B,
monitoring that doc,
Yeah.
to use an N8N workflow to execute a deployment script and launch a new landing page, all without a human ever prompting either of them?
If there's no governance layer, how do you stop an infinite, expensive loop of AI agents just talking to each other and building things in the background? That is the horizon this protocol opens up. It is a wild thought to end on. Subscribe to AI Frankly wherever you listen to podcasts, Apple Podcasts, Spotify, YouTube, or visit afrankly.substack.com for the full articles and show notes. If this helped you think differently about MCP, share it with someone who's still repasting their project brief every session.
AI Frankly. We having fun yet?